We didn't start the fire. Do 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 do. Okay, we're here looking at a force problem. This is in Unit 6, problem 20.2. It's a vertical problem. What we have here is a firefighter who has a weight of 812 newtons, so that's their weight. They're sliding down a vertical pole, and the firefighter's speed, her speed's increasing at the rate of 1.45 meters per second squared, so that's an acceleration. We know that gravity and friction are the only two significant forces acting on her, because if you imagine you jump on a fire pole, you grab onto it, and you slide down because, gravity's pulling you, and you're holding on, so there's some friction, your hands are kind of feeling it a bit, which slows you slightly. We just want to know what's the magnitude of the frictional force. Now, we haven't talked about friction yet, but it is just some force, some friction. That's all we're looking for here. So let's just draw a free body diagram. When we draw the diagram, we know that the firefighter's weight is pulling her down, and we know that friction is going to slow her somewhat. But friction's got to be smaller than the weight because she is falling down, so we know that. We also know that she's accelerating at 1.45 meters per second squared downward. So when we pick positive and negative directions, let's actually pick down to be positive this time. Let's pick up to be negative. And that'll mean that our acceleration will be positive and the weight will be positive and friction will be a negative amount. So if we go and set up our sum of forces equals a mass times an acceleration, this will be the weight minus the friction, so we're adding the negative quantity of friction. So weight minus friction equals the mass of the firefighter times the acceleration here. In this case, we know the weight. It is 812 minus friction, which is what we're looking for, equals mass times an acceleration of 1.45. Now, what is this mass here? Well, we know what the weight is, and we also know that weight equals mg. So if we know weight is 812, that equals mass times gravity, which is 9.8. If we simply divide by the 9.8 on each side for gravity, that'll give us the mass here. And if we take 812, divide it by 9.8, we'll find that the mass of our firefighter is 82.86 kilograms. So we can just plug in down here for the pink spot, the 82.86 kilograms. And then now we just need to solve this. If we multiply the 82.86 times 1.45, we get 120 newtons. That's going to equal the 812 newtons minus F. And if we just want to solve for F, we could add F over here, get rid of it here, and then subtract by 120 on each side. And that will give us 812 minus 120, or 692 newtons equals the force of friction. Okay? And that's it. That's all we want on there. This problem was a lot of just, let's set up a picture, let's pick positive and negative directions, write out F equals ma, and then our last little bit we had to remember was that weight equals mg, solve for that mass, and then just solve this out in the bottom. So nothing too bad here, nothing we haven't done before. Just thinking about these in up-down motions, the vertical directions, rather than the horizontal left-right. And really just remembering that weight equals mg is an important thing. Even though we haven't talked about friction, we can just think of it as a force right now, opposing your motion, kind of slowing you down, and we were able to find it there. So nothing too bad. With that, this problem is finished. Adios. Take it easy. I'll see you in the next one.